Very good morning, students. We are here with our new topic, phenols, part 2, which will cover the methods of preparations of phenol. So, this topic is relevant to the third semester BSc Chemistry students, and it is presented by Ms. Nisha Tevatia, Chemistry Lecturer in Government PG College, Faridabad. So, if I start with the first reaction, or we can say the method of preparation of phenol, that is benzene sulfonic acid. Yes, from benzene sulfonic acid we can easily prepare phenol, as we can say that benzene sulfonic acid can be formed with the help of benzene and the reaction with oleum. As we all know, oleum is fuming sulfuric acid. So benzene sulfonic acid can be obtained from benzene by reacting with oleum. This benzene sulfonic acid can be treated with molten sodium hydroxide at high temperature. Means we have to treat the benzene sulfonic acid with sodium hydroxides at very high temperatures so that it can encourage the formation of sodium phenoxide. After the formation of sodium phenoxide, the second step will be the workup process, right? So in the workup we finally get sodium phenoxide converted into phenols, as you can see in the reaction below. Okay, so the second method is from diazonium salts. This is the very famous as well as the important method of preparation of phenols, as in this, firstly, we can convert the aniline into benzene diazonium chloride. And how it will be carried out? It will be carried out by treating primary amine. Please note down this thing, that only and only aromatic primary amine, when on treatment with nitrous acid, that is NaNO2 plus HCl at 273 to 278 Kelvin, that get treated and get converted into BDC. BDC is known as benzene diazonium chloride, as you can see in the reaction below, the very first step, where aniline gets converted into BDC by the reaction with NaNO2 and HCl. And please note down the temperature conditions, because temperature conditions are very important in this reaction, that is 0 degree centigrade to 5 degree centigrade, or we can say that 273 Kelvin to 278 degree Kelvin. After getting the BDC, which is very highly reactive in nature because of the presence of the very reactive dinitrogen, so we can say that on warming it with water we can get converted into phenols. As you can see in the second reaction, BDC get converted into phenols because N2 get easily escaped out along with HCl. Next, it is Dows process. The third process in the formation of phenol is Dows process. Dows process basically involved the reaction of chlorobenzene with sodium hydroxide at very high temperature and pressure condition to get converted into phenols. Dows process is also very important process, as this method is used for commercial production of phenols. We can see that in this particular reaction there is a chlorobenzene and it is treated with the aqueous alkali. Aqueous alkali basically sodium hydroxide, commonly it is we are taking it as a sodium hydroxide, and at 623 Kelvin and 320 of atm pressure we are getting sodium phenoxide. So sodium phenoxide in this particular reaction get converted into phenol after treating it with dilute HCl. Basically it is a workup process where sodium phenoxide get easily converted into phenols. Okay, if you talk about the mechanism of this particular reaction undergo in the Benzyne mechanism. So what is Benzyne mechanism? In Benzyne mechanism, the chlorobenzene, when first treated with sodium hydroxide, aqueous sodium hydroxide, it is acting as a base, and the base firstly take up the proton of chlorobenzene, which is highly acidic in nature, and after taking up the proton the rearrangement of electron will take place like this and we will get a benzyne. So if someone asks you what kind of mechanism is followed in Dows process, so the answer will be benzyne kind of mechanism. After benzyne is treated again with sodium hydroxide, this kind of substitution takes place, and on substitution finally we are getting the workup process, and hence the product will be phenol, as you can see in this particular benzyne mechanism. Okay, what are the effects of substituents on this reaction, right? We all know that on a particular reaction there is some kind of effects, either positive effects or negative effects, that is acting on the particular reaction because of the particular substituents as well as their position. Okay. So in this benzyne type of mechanism we have studied Dows process, and in Dows process basically the reactions get activated, or we can say that reaction get enhanced by the presence of strong electron withdrawing group at ortho and para position. Firstly we will talk about the electron withdrawing groups. Why only electron withdrawing groups? Because electron withdrawing group facilitate the conversion of benzyne intermediate by the abstraction of proton by presence of sodium hydroxide. And when sodium we can say that strong electron withdrawing groups are present only at ortho and para position, the reaction effect is pronounced. Why only at ortho and para position? Because the effects are studied by the resonance effect, and we all know that resonance effect is more pronounced on ortho and para position of particular aromatic ring instead of the meta position, where only inductive effect takes place, right? So as the number of electron withdrawing groups increases, hydrolysis of chlorobenzene becomes more easier, because we can see that by the presence of electron withdrawing group there is acceleration of the reaction because of some kind of resonance effect. So here we can see that in the presence of one nitro group at chlorobenzene, that is para-chloronitrobenzene, the reaction takes place in the presence of 15% of NaOH and dilute HCl, right? As you all can see that. But what about this? So in this we can see that there is 2,4-dinitrochlorobenzene, that is presence of 2 nitro group, and it requires the presence of only aqueous sodium carbonate only in the presence of 403 Kelvin of temperature, and we can easily get the conversion of this Cl group into the OH group, that is we will get 2,4-dinitrophenol from 2,4-dinitrochlorobenzene. Similarly, in this third case there are number of 3 nitro groups present over there at this kind of position in the chlorobenzene. This is basically called 2,4,6-trinitrochlorobenzene, and it requires very dilute conditions of this hydrolysis and to get converted into 2,4,6-trinitrophenol. So from these type of 3 reactions we can easily conclude that as the number of electron withdrawing group increases, there is the more leniency of the reaction, that is less and less drastic conditions will be required by the reactant to get converted into the product. The next one is from isopropylbenzene. So isopropylbenzene is commonly known as cumene. What is cumene? Cumene is a compound basically obtained from benzene after the Friedel-Crafts alkylation of it with propylene, right? So in the presence of propylene, benzene gets converted into isopropylbenzene, which is commonly known as cumene. As you can all see in the reaction given below, the very first step is the conversion of benzene into isopropylbenzene, also known as cumene. So cumene in the presence of air, that is it will get converted into cumene hydroperoxide in the presence of air, or we can say that aerial oxidation of cumene convert it into cumene hydroperoxide, as you can see in the step number 2. We will further discuss the mechanism of this particular conversion. So cumene hydroperoxide in the presence of dilute acids get converted into phenol as well as the acetone as a byproduct. So phenols can be prepared by benzene by this particular method, that is known as from isopropylbenzene we get converted into cumene. Okay, so here is the mechanism of the first step, that is cumene on aerial oxidation gives cumene hydroperoxide in the presence of a radical initiator, because it is a radical kind of mechanism. So how this mechanism or reaction is carried out is explained with you. In the presence of radical initiator, firstly H radical will be abstracted out, and hence we'll get this kind of second product, that is a radical product, which in presence of dioxygen get converted into the third one, and third one again undergo, because this is a propagation type of step, it will again react with isopropylbenzene and finally get converted into cumene hydroperoxide. And further this cumene hydroperoxide get converted into phenol as a main product and acetone as a byproduct. How it will be carried out? So it is carried out in the presence of acid. So acid firstly protonate the OH, and hence we will see that there is a elimination of the protonated water, and after there is a elimination we get a positive sign. After this elimination there's a kind of rearrangement. Rearrangement means when OH bond breaks out, there will be the transfer of this benzene ring towards the oxygen, and from where the benzene ring gets transferred we'll get a positive charge because of electron deficiency over there. And this particular kind of carbocation is resonance stabilized due to the presence of oxygen's lone pair over there, and after the stabilization of this carbocation we'll get the positive charge on oxygen, which is highly unstable condition, so it will easily try out to get forwarded in the reaction in the presence of water, as it is shown below. Again there will be an addition of water and we will get the protonated water product, which on transfer of the proton get converted into the final products, that is phenols as well as acetone. So that's all for today's lecture. Thank you so much.